We will study
Forces. Force. Force is defined as a pull or push that changes or tries to change the state of rest or motion of an object. The direction in which the force is applied is called the direction of force. When force is applied to an object, force can make a stationary object move. Force can stop a moving object. Force can change the direction of a moving object. Force can change the speed of a moving object. Force can change the shape and size of an object. Absolute units. SI unit is Newton N. In CGS system, dyne, 1 N is equal to 10 to the power 5 dyne. Gravitational units. SI, kilogram weight or kilogram force, kgWt or kgf. 1 kgf equals 9.8 N. CGS, gram weight by force, GWt or GF. 1 GWt is equal to 980 dyne.
Absolute units of force. SI unit is Newton N. In CGS system, dyne, 1 Newton is equal to 10 raised to the power 5 dyne. Gravitational units of force. SI unit, kilogram weight or kilogram force, kg weight or kgf. 1 kgf is equal to 9.8 N. CGS, gram weight force, GWT or GF. 1 GWT is equal to 980 dyne.
Types of forces. Force can be broadly classified into two categories: contact force and non-contact force. Contact forces. What do you do to kick a football or push a table? You apply force to get the desired result. The football is kicked with the foot and the table is pushed with the hand. In both these examples, the foot and the hand were in contact with the football and the table respectively. Such a force, where the object on which the force is applied and the object which is applying the force are in direct contact with each other, is called contact force. Muscular, mechanical, and frictional forces are examples of contact force. Muscular force. The force applied by the muscles of an individual, be it human or animal, is called muscular force. For example, activities such as running, non-contact forces. When force is applied from a distance without actual contact with an object, it is called non-contact force. Magnetic force, electrostatic force, and gravitational force are examples of non-contact force. Magnetic force. Magnet is a piece of iron, nickel, or cobalt that can attract iron-containing objects. This property of magnets is called magnetism. A magnet attracts iron nails from a distance. A magnet exerts a pulling force on magnetic materials without being in direct contact with them. This force is called magnetic force. Electrostatic force. The force exerted by a charged body on another charged or uncharged body is called electrostatic force. A charged object can attract another object, even from a distance. Gravitational force. Take a ball and throw it in the upward direction. After reaching a certain height, the ball comes back to the ground. This is because the earth exerts a force on all the objects and pulls them towards itself. This force is called gravitational force. The force between any two bodies or masses in the universe is called the gravitational force. The masses may be as small as a pebble or as large, such as the sun. Friction is the force that opposes the motion when two surfaces are rubbed together. It causes the transfer of electrons from one object to another. The object which loses electrons acquires a positive charge, while the object which gains electrons acquires a negative charge. Let us do an activity to show the electrostatic force of attraction between two objects. Take a paper and a sheet of paper. Tear sheet of paper into smaller pieces. Now take the scale and rub it on your hair and bring it closer to the tiny pieces of paper and observe. You will observe that pieces of paper are attracted towards the scale. This force of attraction is termed as electrostatic force. Properties of charge. Two charged particles separated by a finite distance experience a force of attraction or force of repulsion, depending upon the nature of the charge. Similar charges repel each other, while dissimilar charges attract each other. When electrons are transferred from one object to the other, sparks or shocks of static electricity are sometimes observed, especially when the air is dry. Lightning is simply a bright flash of electricity that is caused during a thunderstorm. During thunderstorms, the strong air currents cause the water and ice particles contained in the clouds to collide against each other. It is believed by scientists that these collisions in the thunderclouds create electric charges, positive and negative. Further, the positive and negative charges separate from one another, wherein the negative charges move towards the bottom of the cloud and the positive charges dwell in the upper and middle regions of the cloud. The negative charges in the cloud cause positive charges to develop in the area surrounding the cloud and on the ground below. The electric charges get stronger and make the cloud negatively charged, and the surface of the earth positively charged. The electric charge caused between the earth and the cloud leads to the occurrence of lightning.
We will study
Pressure. Cutting an apple with a blunt knife was difficult, while cutting the same apple with a sharp knife was much easier. Force applied by a sharp knife is more, because the surface area of its cutting edge is less than that of a blunt knife. For the same reason, carrying a bag with wide straps is easier than carrying a bag with thin straps. The SI unit of pressure is Newton per square meter. Characteristics of liquid pressure. Pressure in liquids has the following characteristics. Pressure in a liquid increases with depth. A liquid exerts the same pressure in all directions at a given depth. Pressure in a liquid increases with an increase in the density of the liquid. A liquid seeks its own level.
Thrust and pressure. Take an empty glass tumbler, a glass bowl filled with water. Now push the tumbler into the water in the glass bowl as shown. You will observe that when you tried pushing an empty glass tumbler into the bowl of water, you must have immediately felt some resistance, as if something was pushing the glass tumbler upward. This was due to the pressure exerted by the water on the glass tumbler. When a force is acting vertically downwards or normal to the surface under consideration, it is called thrust. Therefore, pressure can also be defined as thrust per unit area. Pressure is equal to thrust upon area. SI unit of pressure is equal to SI unit of thrust upon SI unit of area, equals to Newton upon meter square equals to Newton per meter square. Pascal is also denoted by Pascal. 1 Pascal is the pressure exerted by 1 Newton of thrust on 1 square meter of area. The layer of air surrounding the surface of the earth up to 800 km is called atmosphere. Atmospheric pressure means the pressure exerted by the weight of the air above us. But this pressure is never felt by our body. This is because the pressure inside our body balances the atmospheric pressure. This is the reason why we do not get crushed by the immense pressure exerted on our body. An instrument that measures air pressure is called barometer. The unit of air pressure is bar. Effects of air pressure. Let us perform an activity to understand the effect of air pressure. When we blow air into a balloon, the balloon inflates. The pressure in the balloon is maintained due to the collisions of the air molecules on the inner walls of the balloon. This keeps the balloon inflated. Further, if we keep inflating the balloon, after a certain point it bursts. This happens because the pressure exerted by the air particles on the walls of the balloon exceeds the pressure exerted by the air. Take a plastic bottle and pour hot water in the bottle. Put on the cap and pour some cold water on the bottle. After the lid is screwed onto the bottle, the warm air inside the plastic bottle pushes out on the sides of the bottle and the cooler air outside the bottle pushes in. Warmer air has a greater pressure, so the air inside the bottle is pushing harder than the outside air. When cold water is poured over the bottle, the air inside the bottle cools down. Colder air has a lower pressure, so there is now a lower pressure exerted by the air inside the bottle. The air outside the bottle now has a higher pressure than the cold air inside the bottle, and this high pressure crushes the bottle. Let us perform an activity to experience that air exerts pressure. Take a syringe without needle. Now close the uppermost part of the syringe with your thumb and push the knob at the other end with your finger and then leave it. You will observe that the piston of the syringe is pulled back. This is because the air inside the syringe exerts a counter pressure against the pressure exerted by you. Now press the knob of the syringe again. You will notice that the knob cannot be pushed completely. This is because the air present inside the syringe exerts pressure. This experiment clearly demonstrates that air exerts pressure. Applications of air pressure. Atmospheric pressure has some uses too, and it is the reason behind some of the experiences in our daily lives. One of the uses of air pressure is drinking with the help of straw. Have you ever experienced drinking cold drinks or water with the help of a straw? Let us understand the concept behind it. While drinking a liquid with the straw, we suck the air present inside the straw. When the air inside the straw is sucked, the pressure inside the straw decreases than the atmospheric pressure. The atmospheric pressure causes the liquid to rise in the straw and we are able to drink it. A hand pump also works on the principle of atmospheric pressure. Pumps are used to raise water from underground wells. They consist of a cylindrical metal barrel with a tube at the side near the top to act as a spout. At the bottom of the barrel, where it joins a pipe leading to the well, there is a valve B which is normally shut. A plunger carrying a leather cap and fitted with a second valve A is moved up and down inside the barrel by a handle H. To start the pump working, you first pour some water on the top of the plunger. When the plunger moves down, valve B closes owing to the force of gravity and the weight of water on it. At the same time, water inside the pump moves up through valve A into the space above the plunger. On the upstroke, valve A closes. Also, as the plunger rises, water is pushed up the pipe through valve B by atmospheric pressure acting on the surface of the water in the well.